At the start of projectiles on an inclined plane, we need to get used to writing down the equations in terms of different accelerations due to gravity that doesn't exist on the horizontal plane. So let's do our diagram that's pretty consistent within these questions. We have a particle, here's our horizontal, here's our inclined plane, and we have a particle projected up the inclined plane at a certain angle. We'll call it angle A and we'll call it angle B here. And in these questions, what we do is we allow our inclined plane to be our new x-axis or y-axis. And we have a perpendicular to that going this way, which would be our j. So at a moment in time, this particle, let's say it's here, it has gravity attached to it, bringing it back towards the center of the earth, down in this direction. So let's create a right angle triangle here. This angle here and this angle here are the same. This is a right angle, meaning that this one has to be the angle B. So this being gravity, my I and J axis now have different components with acceleration. You can see here, opposite the angle B is my I axis. So opposite will be sine. So G sine B will be my acceleration here in the I direction, and in the J direction it will be G cos B, that the J is adjacent to the angle B. So these are my accelerations. Now it's important to note here that these are negative accelerations unless the particle is projected down the plane, in which case we'll have positive G sine B for the I axis or X axis, depending on which you choose to write it in. My initial velocity vector here projected in this direction with speed u meters per second is going to be u cos A in the I direction plus u sine A in the J direction. So my velocities, my velocity in the I direction is equal to u plus AT, so the u cos A, my acceleration minus G sine B times t, and then in the J direction it's going to be u, which is u sine A minus the acceleration G cos B times t. There are my velocities. Now let's look at the plate displacements. S of x ut plus a half at squared. So u again being u cos A times t plus a half times acceleration, which if we're going up the plane minus G sine B times t squared. And just tidying this up, we get u cos A times t minus G over 2 sine B times t squared. So you should see that we just get the opposite with the y. So displacement in the y is going to be u sine A times t minus G over 2 by the cos of B times t squared. You don't have to memorize these. You should really set them up every time you have a question. It doesn't take that long. Draw your diagram out, get used to drawing the diagram up above in blue and red, and get really good at starting the layout of these questions before you start to attempt any of the exam type questions. The ones following in the book are pretty straightforward and just they're kind of testing your skill set and getting you good to the repetition of setting up these questions. The other thing to note here is that or the displacement vector which has come up in exam questions is equal to, it's just the position of x plus the position of y. So you get this big long thing here, this guy added to this guy for your displacement vector.